So I'm going to talk about how we are leveraging artificial intelligence in a really boring area called IT operations, right? But before that, so we in the morning we had discussions around 2 or 3 areas which are not really AI, right? So we started the discussion with automation, and a lot of data points were put in for automation. So just a few examples and my thoughts around automation and AI before we proceed to the boring topic of IT operations and how we are leveraging that. If we look at machines, right, we've created them. I flew 8,000 miles in 8 hours and reached here, right? Could I have done that using my legs? Could I have walked, from India to London? I couldn't have done that. We drive cars today, and I mean, none of us can run as fast as a car, and we just ignore these technological advances as and when they come, because that's maybe we are human, right? So we just ignore a technological advance when it comes, and it seems very normal. If you look at touch screens, they were science fiction a few years ago, and now everyone is using touch phones without even realizing the kind of innovation that would have gone into creating this technology, not just from a software perspective, but a hardware perspective, battery, device, everything. So when it comes to automation, we have already crossed the boundaries of human limits. Machines can do much better job than a human being, and the same is true with. So there are 2 terms. One is a specific AI, and the other is a generic AI. So yes, we are years away from a generic AI which can think like a human being, do all the varied stuff that humans can do. So I, as a human being, can code. Some of you may, be writers, authors. Some of you may be teachers. All of us can drive cars. We can do a lot of varied things, right? And that's what a generic purpose AI is, which could mimic what a human being does. And that's the ultimate goal of all the technologists in this area, to create something which can replicate what a human does. But let's look at more pragmatic stuff that is available today. And it is not just about replacing jobs. It is not about competing with a human being. When it comes to specific artificial intelligence, it has already surpassed the human capabilities. As an example, none of us can go and index the whole internet, but Google does that, correct? None of us can find out keywords and find out information from terabytes of information which is available today, but machines can do that. So when it comes to specific purpose AI, a machine has got certain things which a human does not have. I mean, I'm sure all of us have a lot of books on Kindle. Have you read all of them? How much time would it take for me or you to read a book on a new operating system which is released, or a new application which is released? A lot of time. We take time to ingest data, process it, analyze it, memorize it, and then recall, right? So there's a lot of time that a human being takes. What about a machine? I have an example of how we are leveraging the Watson technology for service desk, but Watson can ingest gigabytes of information in a day, which a human being cannot. So another example is algorithmic trading. Most of us may be trading in stocks or mutual funds. Can we place orders in milliseconds? Can we look at all the information which is flowing on Twitter, on news channels, and take decisions and buy and sell? By the time we click the button, the algorithmic trading systems would have already traded 5 times. So the machines which are based on artificial intelligence have already surpassed human intelligence and human capabilities in specific areas, which is search engine, text extraction, analytics, and in the areas of algorithmic trading, etc. Yes, the generic purpose AI still remains a dream where a machine can do varied tasks. We also had a discussion around automation, that the cost of machine, robots, and the cost of humans, right, and how the cost of humans has increased, and it is economically viable to use machines to do production. And if you look at the generic purpose AI, there is a metric which has got created. It's a company sponsored by Elon Musk, and they've created a metric called the connections that a neuron can make in per second, right? Using that metric, if we are to build a machine today, it will cost us, I don't recall the exact number, but it is $4,700 to $15,000 an hour to run that machine. So that's the cost of the human brain, right? The kind of corrections we make in our neurons, equivalent machine will cost this much. But if you look at just a few years back, we had the Human Genome Project, right? it took $3 billion and a lot of time for the human genome product to come out with their genome sequencing for humans. How much does it cost it today? It's 8 hours and $1,000. Can a human being sequence their own DNA without the help of machines? The answer is no, we will never be able to do that. So what I'm going to talk about now is how we are leveraging the AI technology, and I'm not going to talk about automation, but be very specific to how we're leveraging the artificial intelligence capabilities in the IT operations. So if you look at my earlier examples, IT operations is very similar. IT operations, and there are analogies, right? So IT operations, a legal profession or a profession which involves medical science is very similar. How are they similar? Because it involves reading a lot of information which is available. It involves reading a lot of literature which is coming out every day. It involves digesting all this information, analyzing it, and then coming out with recommendations. What does a doctor do? A doctor reads a lot of information which he goes through his graduation. Then every day there are new papers, new medicines, new ways of diagnosis which are coming in, and he reads all of this information and keeps his knowledge up to date. The second information that a doctor has is when he practices on humans and he sees the results, and through his experience of implementing that knowledge, he gains experience. So what we have done is we have combined both these approaches of gathering knowledge through reading documents. A lot of humans, as humans, we gather knowledge through reading. And then the second is learning through experience. So what we have tried to do is combine both of these approaches in our solutions and use them for IT operations. And the whole idea is to shift left so that machines do most of the simple stuff and the complex jobs are done by the humans. So what are the various areas in IT operations where we can leverage artificial intelligence? There are two different areas where we can leverage AI. First is analytics. So if we look at IT operations, there is a lot of data which is available to us. There is capacity planning that we need to do. There are hundreds and millions of events which get generated from IT systems. We need to analyze all of this data and maybe present a report which states that this is the state of affairs of your application, or these are the problems in your infrastructure, or these are the things or actions that you can take to improve your infrastructure and applications. We call it analytics. So the AI machines have got the power to look at 1 million events and find patterns in the data in a similar fashion that it can find patterns in human genes, right? Or so essentially it is pattern finding. And what do we do with pattern finding? When we find certain patterns in the data, we are able to predict certain things. So the two use cases are leverage the data which is available to you, analyze humongous amounts of data because a machine can do it, a human cannot, and then based on the patterns that you are able to find, predict the future. An example of this would be if I see that event A and event B occur in 6 hours duration of each other, right? I will be able to predict that if an event A has come in, which has no relevance to my IT infrastructure or application, it is not an availability issue. But if another event happens after 6 hours, which can bring down my mission critical systems, then that's a correlation that a machine can perform. A human cannot do that because a human cannot read through 1 million events and find patterns. So when the machine finds this pattern, it can then apply and say 6 hours from now, there is a high probability that your mission critical database may go down and you may want to take some action. So this is an example of AI which can look at events, find patterns in data and provide this. So the second use case is robotic process automation. We talked about automation, we've talked about runbook automation, data center automation. All of these automations have existed in the IT space for ages, right? We've been using runbook automation systems. We've been using data center tools for monitoring. All of these are automation which have enabled us to have greater control over our IT infrastructure and applications. But where does AI fit into robotic process automation? And what is robotic process automation? How are we leveraging artificial intelligence to do far higher percentage of automation in our environment? So if you look at a robotic process automation tool, it has the ability to read through documents. It has the ability to do natural language processing. It has the ability to find out the root cause of what the problem could be. And it has the ability to then fire that automation to bring up a system which has gone down, or to ensure that a system is self-healed. or to ensure that it is preventive healing. So a system needs to have a few things. It needs to have a knowledge repository. It needs to have a brain which can read this information and map it to what needs to be executed. So here if you see in this diagram, all the events are flowing in from various IT infrastructure components into an execution engine. But the brain behind this is a cognitive engine which has capabilities to process natural language. It has capabilities to do pattern matching around data. It has capabilities to predict, and it has capabilities to instruct this execution engine to do something. So earlier we did not have this piece, but we already had this piece which was coded, and a runbook automation would run in this fashion. The other important factor is that this is unstructured data. This data knowledge repository is documents, it is websites. It can go and read a Microsoft website or an Oracle website or a Google website or any product website and understand what the issues are and what the solution is. And then it can also be taught by humans. And as I mentioned earlier in the example that I took about a doctor, right? Humans learn from experience. So it takes the human experience into play, and combining both of this, it is able to generate a confidence score. And a confidence score will mean that I am 90% confident that this particular issue will be resolved by using this particular action. And then, just like a human being, it will take a decision to fire a solution. And the other way that this engine learns is the ability to learn from its own actions. So it's learning from the knowledge repository, the human engineers, and its own actions. So it's how do humans learn, right? If I've made a mistake, I would remember that I've made a mistake and I will not try to repeat it, correct? Similarly, if the cognitive agent here has made a mistake, it will know that whatever action I took was wrong, and I need to look back and see why that wrong action was taken, or why that knowledge, what is the source of the knowledge that resulted in a wrong action. And then it brings down the confidence score of that action so that it does not repeat the same mistake just like a human being will do. So that's what robotic process automation is all about. And you can look at the benefits since it automates a lot of stuff. It automates mundane tasks. It is able to identify issues. It is able to resolve issues. It brings higher availability to your infrastructure components as well as on your applications. So you have much higher availability, much less human intervention, much lesser errors using the AI technology for robotic process automation. What does it take to build this? So these are the 4 areas. It needs to have natural language processing capabilities, and there are a lot of algorithms which are used for understanding natural language which go into the system. It needs to have pattern matching and rule based systems. So you need to have the ability to match pattern across events, across ticket, across infrastructure elements and application areas. And then you need to have statistical modeling techniques, regression, so that you are able to predict things. And you need to have classifiers which can classify various data points that is given to the system into various buckets. And then you have the machine learning which will learn from its own actions and from humans. Combining these 4 areas, we create the robotic process automation engine. And power of one click, you click a button or it works in the background, you don't even click. It is able to integrate with various IT systems so that it is completely holistic in its approach, and you are able to resolve all kinds of problems. The other area that I wanted to talk about today is around the virtual service desk, and we had sessions in the morning where we talked about chatbots and chat agents for various kinds of applications. You can have a mobile chatbot agent, or you could have a device like Alexa which you can use for talking to it. So there are various modes of communication that you can have with systems. And so these are the use cases for a cognitive service desk agent, a service desk agent in IT operations area. Why is this a good use case for applying AI and cognitive agent? Is because as I mentioned earlier, right, there's humongous amounts of data available there. Even if a human wants to learn a new operating system, it will take him time to learn. If he sees new documents being uploaded or new documents getting created on various websites, it will take him time to learn. And even if there is past data available for hundreds of thousands of tickets, a human being will still take a lot of time to understand all of this data and increase his knowledge. So, what does a cognitive service agent do? A cognitive service desk agent has the ability to read. And why is it cognitive? It is cognitive because it is mimicking a human behavior, which is the ability to read documents and be aware of its environment and be able to use that information and create context or focus, right. So, if you've looked at the Watson Jeopardy game, it is the ability of the cognitive agent to find the focus of the question, right, and it is the ability of the cognitive agent to take input in any kind of format, right. I may ask the same question in a different manner, and people sitting in this room, everyone may ask a same question in different way. You may form different kinds of sentences. I may give an input to the system which has spelling errors, right. We are used to chatting and WhatsApp and SMSs, and the SMS language or WhatsApp language is very different than the natural language, so-called natural language that we use. I'm amazed at the term natural language. Humans created it. So, how do you ensure that humans are still able to talk to a cognitive agent using things like grammatical mistakes? You have spelling errors when you ask a question, and the system is still able to understand what you really want. So, there may be hundreds of chat agents or software which do chatting available in the market, but the whole idea is to have something which can really find the focus of the question and provide the relevance. So, the relevance of the solution, the relevance of understanding the question, the accuracy is what matters the most. If your chatbot agent is not able to accurately understand the question or is not able to provide the right answer, it will lose faith of the user community really quickly. So, we are leveraging Watson here, and what we have also done is we have built preprocessors. So, you need to build preprocessors so that the data that is available to you in your past chat logs or your service desk tickets gets fed into Watson in the correct format. So, this is how the whole system will work. The end users face issues. They can talk to the cognitive agent using ChatOps, which is a chatting interface, or they can use voice to text and talk to a system like Alexa, or use your mobile phones to talk to the system, and the cognitive agent then leverages its knowledge to resolve and provide answers to end users. And does it replace humans? The answer is yes. You don't need a human being to support once the number of tickets go to this cognitive agent. What is the percentage that we are seeing getting resolved by a cognitive agent? We are seeing 40 to 50% is the number of tickets that we are seeing which gets resolved by a cognitive agent easily. The other beauty of the system is that since it learns by experience, the more data you provide it, the better it becomes. Just like a human being, the more tickets I resolve, the better service desk agent I become. The more documents I read, better informed I will be in my decision making, right? So the system has the ability to not just learn from documents, but learn by experience. And once you deploy the system, the accuracy of the system and the coverage goes up. So, these are some of the technicalities. It takes the questions and topics, it breaks down these questions, it does natural language processing, use hundreds of algorithms underneath to understand the most critical focus of the question. Then it has the ability to read the documents which are the answers to a question, and it then matches the correct answer to the question. And it is not just one answer that it provides. Internally, it ranks all of these answers in a probability score. So, you get a probability score stating the confidence score of this answer to this particular question is X percentage. And then based on the confidence factor, it will answer or it will not answer. So, if it thinks that the confidence score is too low, it is not going to provide a wrong answer, right? And if the confidence factor for that answer is high, it will provide that answer to the user. Just like humans, right? We would weigh our answers. The answer to this multiple choice question is A, B, or C. And based on the confidence factor between A and B, we will choose either A or B. Similar fashion, the cognitive agent will answer. So, what are the benefits of a cognitive service agent? It is not just about cost arbitrage, it is not about automation, it is not just about human versus the machine. It is also about the ability to provide a user experience to our customers, which is equitable to what they're getting in a Siri or a Cortana or any personal assistant today. And in the earlier session, we talked about, right, how we feel when we have the IT systems at home and how we have, how the IT systems at office look like. So this is an attempt to ensure that people get similar user experience and quality in service desk. That is what they're getting from their personal assistants on their mobile phones today. And rest of the things, yes, you have an ROI, yes, it brings down cost, yes, it is much more intuitive. All of these factors do exist. Have you seen this movie? No, maybe someone will create this in the near future. But the whole idea here is that where is the boundary between a machine serving a human still and a machine going intelligent itself. So I think today, if you look at certain categories, the machine is not just doing a job which is equivalent to a human being, but a machine is doing a job which is better than a human being. If you talk about accuracy of search results, so Google ran this AI engine, a lot of the search results now are driven through an AI machine, and they compared the results of the AI machine versus humans who were search engine optimization experts, and the machine was better than the experts. So we are moving into an era where it is not about competing with the machine. The machines have already surpassed not an average human, but an expert in a field. Similarly, there was a talk around IBM Watson, and some of the results from diagnosis were that the machine is able to better diagnose a disease than a doctor. So we've already entered an era where a machine is better than a subject matter expert, not just an ordinary human being, and it remains to be seen whether we create a Skynet or not. Thank you.
Thank you very much, Navin. We do have time for just one question.
Yes, sure.
There is one from the audience.
Yes?
Yes?
I was interested in
Sorry, let me just, so people at the back can hear you.
I was interested, thank you very much, interested in the IT operations. Of course, one of the benefits is cost reductions. Could you share a couple of examples of either in absolute or relative terms of how much does it cost, how much does it cost to run, and what is the cost reductions that you get?
Okay. So I think it's a very good question on, and cost is one of the important factors anywhere when we do automation, right? So if you look at the cost reduction, it is a function of two things. One is the scale of operations, right? So, and I'll take a very simple example. You don't create customized cars by assembly line because you make too few of them, right? So the cost benefit is exponentially higher if you have large scale operations. So if you look at 1 million servers, right, all running a homogeneous application, the cost reduction will be 90%, 95%, because you don't need any human beings to do any work, right? 5 people will be able to support 1 million servers if it is all similar. And if you have a 500 server environment, the benefits will be lesser.
I understand the economics. I'm asking, do you have some real examples?
Okay, so from a real example perspective, the cost benefits start from 25% and they go as high as 60% in a homogeneous cloud kind of an environment. Just using robotic process automation.
Thank you very much, Navin. Thank you for being with us today. Thank you.
Thank you.